In this lesson, we're going to look at solving quadratics again. And remember, the meaning of that is to find the value or values of x that make the equation true. This second method is called using square roots, and it's really useful when you have a squared expression by itself on one side of the equal sign. And the step involved is to take the square root of both sides and to possibly simplify. So this works when you don't see an x term, but only an x squared term and possibly a constant term. So if we look at a couple of examples, the first one is 4x squared minus 25 equals 0. So if I rearrange that equation by adding 25 to both sides, I end up with 4x squared is equal to 25. I can then divide both sides by 4 and have x squared equals 25 over 4. Now I have a perfect square on the left, so I can take the square root of both sides and say that x is equal to the positive or negative square root of 25 fourths. And remember to always simplify your radicals if possible. And we can do that because the square root of 25 is 5 and the square root of 4 is 2. So x is equal to plus or minus 5 halves. Let's look at another example. If I have 2x squared plus 7 is equal to 0, I can follow the same steps. I'll give you, you might want to press pause and just follow the exact same steps for example 1. This one does not turn into a nice whole number, though you will have a radical in your final answer. All right, so let's rearrange this equation. I now have 2x squared equals negative 7, or x squared is equal to negative 7 halves. If I take the square root of both sides, there's something funny happening with the computer here. Put that down a second. There we go. And I'll take the square root of both sides, so x equals plus or minus square root of negative 7 halves. And remember, when we have the square root of a negative, we can pull I out of that. So we have x is equal to plus or minus I root 7 over 2. Make sure that that root sign encases the whole fraction there. All right, our third example we've got x plus 3 squared is equal to 11. So again, I have a squared term on the left and a constant on the right. So let's just take the square root of both sides there. So I've got x plus 3 then is equal to plus or minus the square root of 11. So if I subtract 3 now for both sides, I've got x is equal to 3 plus or minus the square root of 11. So keep in mind what this means. Plus or minus means there are two solutions. So we have x is equal to 3 plus the square root of 11, or x is equal to 3 minus the square root of 11. And I apologize, that's x plus 3, so I'm subtracting 3 from both sides of the equal sign, so those are all negative 3, plus or minus the square root of 11. And that's using the square root property, which is our second method of solving equations.